Okay, now here's the next two thermodynamic processes which are essentially important. Okay, isothermal process and adiabatic process. I purposely put this isothermal process and adiabatic process together, okay, to explain side by side, because I want to do comparison. Just now, before this, the previous video, I compare between isobaric process and isochoric process. Why I put isobaric and isochoric process side by side? Because I want to make comparison also between these two. Isobaric process is a horizontal line because at constant pressure. Isochoric or isovolumetric has constant volume. That's why it's a vertical line. Isobaric process is a horizontal line. Isochoric process is a vertical line. But for isothermal process and adiabatic process, the difference is isothermal process, it is a curve. Adiabatic process is also a curve, but it has a bigger gradient compared to isothermal process. Isothermal process is not so steep, but adiabatic process is more steep, is steeper. Yeah, the graph is steeper than the isothermal process. Why? Why is it like that? I will explain later. Okay, both of these are curve. Yeah, these are isobaric and isochoric process is a straight line. Horizontal line and vertical line. But isothermal process and adiabatic process, both of them are curve. This one is less steep curve. Isothermal is less steep curve, but adiabatic is a more steep curve. Okay. Now let us first look at isothermal process. Let's begin with isothermal process. What it means by isothermal? The word itself tells you the meaning. Iso means same. Thermal is thermal energy or heat energy. Yeah. Thermometer. You know what is thermometer? Thermometer measure the temperature. Thermometer measure the temperature. So isothermal means same temperature or constant temperature. So isothermal process means constant temperature. Okay. So what law has the temperature constant? Okay. Constant temperature means what law? The Boyle's law. Boyle's law means only the pressure and volume changes. Only the temperature constant. Okay. So it is a P1 V1 equal to P2 V2. Only the pressure and volume changes. Temperature is constant. Okay, Boyle's law. P1 V1 equal to P2 V2. And pressure and volume, they are inversely proportional. So I can say like, for example, if the pressure increase, the volume will decrease, isn't it? Like if this pressure one, it has a lower pressure, it will have bigger volume. If pressure 2 has higher pressure, it will have lower volume. Okay, that's pressure and volume, they are inversely proportional. Okay, P1 V1 equal to P2 V2, that's Boyle's law. So isothermal process is Boyle's law. Okay, why is it temperature constant so important in isothermal process? Okay, what it affects? What is the implication of what will happen? What will happen when temperature is constant? Okay, looking at this equation, internal energy of gas depend on temperature of gas. Okay, so when temperature of gas is constant, the internal energy of gas will also be constant, isn't it? The internal energy of gas is dependent on the temperature. When temperature constant, internal energy of gas will also constant. So when internal energy constant, that means no change in internal energy. Because the gas has constant temperature, so the internal energy of gas will also be constant. So delta U is 0. So isothermal process, very important. the most important concept in isothermal is delta U equal to 0. Delta U equal to 0, and we can bring that to our first law of thermodynamic equation. So when internal energy is constant, delta U is 0. Why delta U 0? Because internal energy is constant. Why internal energy is constant? Because temperature is constant. Okay, delta U equal to 0. So let us look at the, okay, before we go to the first law of thermodynamics, let us look at the PV graph. Let us look at the PV graph. So now, this is point 1 and this is point 2. Condition 1 and condition 2. Okay, just now I said temperature constant. Temperature constant. That means, you see, point 1, it has pressure 1, 200. It has volume 1, 10. And then point 2, it has pressure 2. Point 2 has pressure 2, 100. And it has volume 2, 20. You see that? When you, from point 1 going to point 2, what happened? This is called expansion. Going to the right is expansion. Volume 1 going to volume 2. You see that? From point 1 going to point 2, the volume increase. You see that? You see the what happened? From point 1 going to point 2, the volume increase. Expansion. Volume increase. But what happened to the pressure when point 1 going to point 2? The pressure decrease from 200 going to 100. The pressure decrease. So you see that pressure and volume, they are inversely proportional. For Boyle's law, when volume increase, pressure decrease. Pressure decrease. So same goes to compression. If let's say we go from point 2 going to point 1, point 2 going to point 1, it will be volume decrease, but pressure will increase. The other way around. Okay? All right. Okay? So for Boyle's law, from point 1 going to point 2 is volume increase from 10 to 20, but the pressure decrease from 200 to 100. Pressure decrease. Yeah? One increase, one decrease. Pressure and volume inversely proportional. But what happened to the temperature? These 2 points maintain on the same isotherm line. Maintain on the same isotherm line, 400 Kelvin. It didn't go to the other line. Yeah, 300 Kelvin. It didn't go to another lower temperature line, or it didn't also going to a higher temperature line. Yeah, maybe there's another higher temperature line. It also didn't go to the higher temperature line. It also didn't go to a lower temperature line. It maintained at the same isotherm line, which is 400 Kelvin, because for isothermal process, it's a constant temperature. Unlike the previous 2 processes, isobaric and isochoric, you see that it jumped from one isotherm line to another isotherm line, so the temperature changes. Isochoric process also jump from one isotherm line to another isotherm line, the temperature changes. But for isothermal process, it maintained on the same isotherm line. It maintained at the same isotherm line. Like you see, for this example, from point 1 to point 2, it maintained at the same isotherm line of 400 Kelvin. Because isothermal process, the temperature is constant. Okay, it maintained at the same isotherm line. Okay, okay, that's about the graph, right? That's about the graph. Now, talking about the heat, the first law of thermodynamics. Just now we got in conclusion that delta U is 0 because temperature constant, internal energy is constant. Okay, so isothermal process, delta U is 0. So when delta U is 0, so there's no delta U, it only has Q and W. It only has heat flow and work done by the gas or on the gas. Okay, let us look at this one. Yeah, let us look at this one. For okay, one very important difference between isothermal process and adiabatic process. Isothermal process, it has to be a good conductor container. It must use a good conductor container. That means the heat can easily flow in or heat can easily flow out. But for adiabatic process, it must be well insulated container. That means no heat flows in or flows out. Heat cannot flow through. That's why for adiabatic process, the heat is 0. Okay? For isothermal process, it must maintain the heat must be easily flow in and flow out. Okay, good conductor container. For adiabatic process, it must be a well-insulated container. It cannot flow at all. Okay, let us look at what happened in the isothermal process in detail. Now, if the Q is positive, the W also will be positive. What does it mean by the first condition? Okay, Q is positive when heat is absorbed. Okay, heat is absorbed. So when heat absorbed, no change. The gas does not store the incoming heat energy. It does not store. The gas internal energy remain constant. The gas does not store the extra heat energy that comes in. It does not store. What it does, it straight away use up the energy. It straight away use up the heat energy to do some work. So work done by the gas, volume increase. Maybe I use this graph to this thing that we have learned before. Gaining energy and losing energy. So isothermal process means when Q positive, when heat energy absorbed, it didn't stay inside the gas. The heat energy that enters the gas, it's straight away being the heat energy that entered is straight away being used up to do the work. Maybe I should sorry. Sorry. Again, right. Okay. Yeah. All right. Better. Okay. What happened in an isothermal process means, okay. Okay. Let us look at the first look first at the first situation. When Q positive, heat absorbed into the gas. What happened? Yeah. Look at the first one. When heat energy absorbed into the gas, the heat energy that enters the gas, it does not store inside the gas. It doesn't store as internal energy of the gas. The gas straight away use up the internal energy. Straight away use up the heat energy to do work by expansion. It straight away use up the heat energy that enters to do some work by expansion. Work done by gas. Okay, so that means the gas, it gain energy. Once it gain the energy, it straight away lose energy in the form of work done. It gain the heat energy, and then it lose energy in the form of work done. So the energy just like drive through, The energy doesn't store inside the gas as internal energy. So the internal energy in the gas remain constant. The internal energy of the gas remain constant. Isothermal process. Constant internal energy, constant temperature. This is what it means by the first process. When heat is absorbed, the gas doesn't store the heat energy. The gas doesn't store the heat energy that enters as internal energy, but he used up the heat energy to do work by pushing up the piston. Okay, the heat energy enters, and then the gas gain energy. The gas gain the heat energy, and then the heat energy is being used up straight away to do work. Okay, by expansion. Okay, the second one. When Q is negative, W is also negative. What does it mean? What does it mean? It means that we start from the right-hand side. Work done on the gas, compress the gas, and heat is released, heat is lost. When Q is negative, work done also negative. What does it mean? Okay, look at this one. Okay, first of all, work done on gas. Work done on gas compression. So, when W is negative, work done on gas compression, the gas gain energy. The gas gain energy. But when you work done on the gas gain energy, but the energy that is gained, it does not store inside the gas as internal energy. The energy that enters in the form of work done is straight away being loose. It's being released in the form of heat. Also drive through. You see that? Work done on gas, when you compress the gas, the energy enters, and straight away the energy exceeds in the form of heat. The energy that enters in the form of work done, it does not store inside the gas as internal energy, so the internal energy does not change, remain constant. So the energy that enters straight away exceeds in the form of heat. It gain energy and straight away lose energy. So it doesn't affect the internal energy at all. Okay, that is means by these conditions. So for these two to happen, the container need to be a good conductor container. Need to be a good conductor container so that the heat can easily go in and the energy can easily go out. Okay. Now that's about the first law of thermodynamics. Now let us look at the work done. Okay, work done for isothermal process using the formula nRT ln V2 over V1. If going from 1 to 2, 1 is the initial point, 2 is the final point. Okay, so we are using, actually this equation we derive from the integration. Okay, but we're not going to discuss about integration here. Okay, so work done is equal to nRT ln V2 over V1. V2 is the final volume, or we can say this as this is the final. V2 over V1 is also V final over V initial. V final over V initial. Okay, so nRT ln V2 over V1. Just use this equation. So nRT is also P1V1 or P2V2. Just now PV equal to nRT. You know that this formula, PV equal to nRT. PV equal to nRT. So you can either use the there are three equations for you to choose. You can either use nRT, or you want to use P1V1, or you want to use P2V2, also can. Just make sure you use the right value. Don't use P1V2 and also don't use P2V1. You must be P1 or P1V1 or P2V2. That means, or you just use the temperature. Okay, that means, okay, let's say I use the first one, nRT, then I use the 400 Kelvin, 400 Kelvin temperature, 400 Kelvin, nRT. These two points have the same temperature, 400 Kelvin. Okay, or you can also use the first one. You can use P1 200 with V1 10. That is P1 V1. Or you can also use P2 V2. Yeah, P2 is the 100 and V2 is the 20. Okay, you will still get the same answer. You can either use P1 V1, or you also can use the P2 V2, or you just use the 400 Kelvin temperature. Okay, so there are three ways for you to find the work done of the gas, which is also area under this graph. So the area under the PV graph is actually given by these three formula. Okay, you can use either one. All right, that's isothermal process. So The next video will explain about the adiabatic process. Okay, so thank you.